Hi there, welcome back to Priya's maths classes, and in this video I will talk about logarithmic differentiation. Alright, why do we use this? See, we have seen product rule, chain rule and so on, right? U by V, U into V and forms and so on. So let us consider my dependent variable to be y and have x as an independent variable. When my LHS is a y is equal to something. My RHS is f of x raised to g of x. Okay, as the base I have a function, as the exponent also I have a function. So base raised to some exponent form, both are functions of x. Example, y is equal to x raised to power x, y is equal to x raised to power x squared and so on. If you look here, there is absolutely no way I can apply the rules that we have learned earlier, product rule or chain rule. The only method that I can see now is to go with logarithmic differentiation with the technique I will explain to you in a minute. See, before we go there, we need to remember in mathematics when I just say log, it means I'm talking about logarithm of something to the base e. Okay, now e is an irrational number which lies between 2 and 3. Okay, we don't need to know the specific value here, but anyway it's irrational, but it's something, it's lying between 2 and 3. Alright, we also sometimes some people also use this symbol ln, which stands for natural logarithms. Okay, I don't have to, but in mathematics it's understood. Log means it's logarithm to the base e, because in physics or chemistry I'll have to specify the base, whether it is to the base 10 or e or anything else. Okay, so to the base 10 we call them as common logarithms. Logarithms to the base e are natural logarithms. In mathematics we are dealing with natural logarithms. We can use this or even this symbol is fine. So we have to remember these two things as well. E raised to the power log x is equal to x. So e raised to the power log x is equal to x. Log of e to the power x is x. Okay, these two are very important. And now let me take my function y is equal to x raised to power x. So I can't go with product rule, chain rule or even my quotient rule. So it's not u into v or it's not u by v. It's u of x raised to power g of x. So what do? I'll first take log both sides. Alright, log y is equal to log of x raised to power x. Okay, log of a raised to power m, it's in this form, look here. So log of a raised to power m is your m into log a. This m comes here, m into log a. I'll do the same thing here. So I take log. So log of x raised to power x is x into log x. What did I do? Now what was f of x raised to the power g of x base exponent? I have converted my RHS as a product of two functions. So I can apply product rule. Yes, there you go. So now what you do is differentiate with respect to x. This is important. On my LHS I have log y. Differential of log y is 1 by y dy by dx is equal to x into product rule here, d by dx of log x plus log x into d by dx of x. So x cancels because x d by dx of log x is 1 by x plus log x into d by dx of x is 1. So here I get 1 plus log x. I put that in the bracket and here I have my y, 1 by y, I take it up. So dy by dx is equal to y into 1 plus log x. Is it clear? I think it's clear, right? Okay. So now we'll take another function and what we will do is we'll apply two different methods. Okay. We'll differentiate that function of course, but in two different ways. One is a known method and one is what I just now told you, right? That is logarithmic differentiation. Apply that and we will see what we will get. Whether we get the same answer or different answer, which method seems easier or faster and so on. Alright. Now let me take my y is equal to x squared by 1 plus x. Okay, we'll go with one known method first. Going by the axioms of teaching, we always have to proceed from known to unknown. So let's apply that here. What I would do is, you are familiar with quotient rule, right? We'll do that here. It's in u by v form. d by dx of u by v is what? U into d by dx of u divided by v. I mean to say it's v into du by dx minus u into dv by dx by v squared. It's in u by v form. The same thing I'll do it here. It's v into d by dx of u, which is my x squared, minus v is, sorry, u. This is v into du by dx, v into du by dx minus u. My u is this, u into dv by dx, u into dv by dx, and differential is divided by v square. The whole thing is divided by v square, which is 1 plus x the whole square. And there you go. There you get this v square. So it's 1 plus x. d by dx of x square is 2x. d by dx of, and 1 plus x is, d by dx of constant is 0 of course, and d by dx of x is 1. 0 plus 1 is 1. This is my numerator. Now just take this inside, and that's what I get. So 2x plus 2x square minus x square. When I simplify this, 2x plus 2x square minus x square. So 2x plus x square by 1 plus x the whole square. Okay, this is what is my, what is this? This is my dy by dx. This is my dy by dx. Using which? Quotient rule, right? I know this. Nothing great about it. We already know it. Now let me try to use logarithmic differentiation and see whether the process will get, it's going to become easier or lengthy or whatever it is. Let's see. So it took quite some time for me here. Of course, we cannot just go with one function. We can appreciate the different methods when you apply to different problems. Okay, in some problems you would feel this, the quotient rule is better. In some places you might feel logarithmic differentiation is better, and so on. Okay, it has a lot to do with the complexity, the nature of the functions, and so on. So let's look at logarithmic differentiation. Y is equal to x square divided by 1 plus x. I'll take log y, log both sides. So log y is log of a by b. Log of a by b is log a minus log b. Log of a is this is my numerator, minus log b is my denominator, this. So log y is, now, so I get this log of x square, right? So before that, actually before I differentiate, first I have to take log. So log y is 2 into log x. Yes, I just push this 2 there. Log of a to the power of means 2 in a into log m, 2 into log x minus log of 1 plus x here. And there you go. Apply differentiation. 1 by y dy by dx, because we are differentiating with respect to x. Note that. Okay, that's why. So 1 by y dy by dx is equal to 2 divided by x. 2 into 1 by x, 2 into log x, 2 into d by dx of log x. d by dx of log x is 1 by x minus d by dx of log f of x. What is d by dx of log f of x? 1 over f of x. This is my f of x into d by dx of f of x, right? 2 into d by dx of log x, 2 into 1 by x, which is 2 by x, minus d by dx of log f of x, 1 over f of x into d by dx of f of x. That's precisely what I've done here. And 1 by y dy by dx is equal to 2 by x minus 1 by 1 plus x. d by dx of 1 plus x is, d by dx of 1 is 0 and d by dx of x is 1. So I'm left with 2 divided by x minus 1 by 1 plus x. Just take LCM here. So 2 into 1 plus x minus x, butterfly rule. So it's 2 plus 2x minus x. 2x minus x will give me 1x by x into 1 plus x. And just take this y up. So dy by dx is equal to y into 2 plus x by x into 1 plus x. Alright, so what's my y? So y, yes. What is my y? Let's go back to see where is my y. Yes. We'll go back to where we started. This is y, right? X square divided by 1 plus x. Let's put it in that place. So y is x square divided by 1 plus x. This is my y. And then 2 plus x by x into 1 plus x. And this x and this gets cancelled. There's only 1x on top. And 1 plus x into 1 plus is 1 plus x the whole square. Divided by this is 2x into 2 plus is divided by 1 plus x the whole square, right? It comes down this into this. There you go. And now you have a look at this, my previous working. Okay, using quotient rule. I showed you, right? The same answer. 2x plus x square by 1 plus x the whole square. And the same thing here. Take 2x plus x square. It's nothing but 2x plus x square by 1 plus x the whole square. Okay. So it's just that, you know, how it matters. Sometimes you feel that logarithmic differentiation is faster or easier, sometimes this is better. Generally, okay, if you have a choice to use product rule or quotient rule or logarithmic differentiation, and if the expression on the RHS, the functions contain a lot of powers or roots, root of 1 plus x raised to power 3 by 2 and so on, something like that, then it's better to go with logarithmic differentiation. It makes the process linear. So what it does is you're able to use product rule rather than using quotient rule, basically, when you use logarithmic differentiation, the technique. Okay. One thing is, don't forget to back substitute for y. So when you get y here, you have to replace, okay, what y stands for, and then you have to simplify. So I hope you enjoyed the class, and I hope things were clear. So I'll get back to you with more videos on calculus. So take care and bye for now.